Oh, sorry about that, year 7. Alright, so here's the second part. So I think we just finished on that. Probability of not choosing, so it was 5 out of 6. Hopefully you're okay with that. Alright, so now sample space. So a sample space, for all of those who don't know, is the set of all the possible outcomes of an experiment. So when you toss a coin, you can only get a head or a tail. So the sample space is head, tail, because they're the only two possible answers you can get. Okay, let's see. Next one says sometimes we don't need to list the elements in the sample space, but the number of elements in the sample space. So for tossing a coin, we would say the number of elements in a sample space is 2. So you'll notice this one here says S equals HT. So sample space, the letter that we use, because remember we're mathematicians, we don't like to write much. S stands for sample space or sample, and H and T stands for the answers head and tail. And on this one here, it's number of elements. So you'll notice we've written an N this time. And N brackets S stands for the sample space. So the number of elements or the number of answers are 2 in this respect. So you might have to use notation like that. So that's what it looks like, and that's what it means in case you come across it. Note, when an outcome occurs multiple times, we do not need to repeat that outcome multiple times when listing the sample space. We list it only once. So here's task 2. Identify the sample space for each of the following experiments. Remember, that means to list all possible outcomes of the experiment. The first one has been done for you. Now, I actually did this one the other day with Deanna because she asked me for my help, and I'm just going to double check these and I'll explain them to you with the answers that Miss gave us, because some of these I didn't quite follow myself. So the first one says the multiple choice question has 5 alternate answers, A, B, C, D and E. So our sample space is A, B, C, D and E, all the possible answers you could possibly give. Okay, now the next one said a soccer team plays a match and the result is noted. I wasn't really too sure about this one because that one was a bit weird. So we said, well, it depends on how many goals, doesn't it? So it could be 0, it could be 1, it could be 2, it could be 3, depending on how good the other soccer team is. It could be more than that. So that's what the ... represents. A card is selected from 4 aces in a deck. So if you know anything about a deck of cards, if you don't, you could scroll down to the bottom here, and there's actually a picture of a deck of cards. Unfortunately, they're not in order, but there's an ace here. That's an ace of diamonds. There's an ace here, ace of hearts. There's an ace here, ace of clubs, and an ace here, ace of spades. So they're all the aces. Let me make that smaller again. I've done that, haven't I? Sorry about that. Okay, so you'll notice the answers. Ace of hearts, ace of diamonds, ace of spades, ace of clubs. So they're all the possible aces that you could get, because it says a card is selected from 4 aces. So they're the only 4 cards that you're actually holding. An exam paper is given a grade from A to F. So all the answers are all of those letters, A, B, C, D, E, F. You could get any one of those grades. Question number 5 says a marble is selected from a bag containing 8 red, 4 green, 2 yellow and 6 blue. Now, you might have to write red, green, yellow and blue out depending on how many there are, but I kind of cheated. No, see how it says 8 red? You might have to write red out 8 times, green out 4 times, yellow out twice and blue out 6 times, because that's how many marbles there are. So I'll just double check that one in a moment. And number 6 says selecting a letter at random from the letters of the word alphabet. So you'll notice I wrote down every single letter of the alphabet there. So I'm just going to go back because I know Miss has answers. Sample space and simple probability solutions. Let's just double check our answers. When my internet, there we go. Alright, so I think we wrote most of those. Let's see what Miss wrote here. Oh, okay, sorry, right. Soccer team plays a match. Result is either a win, a lose, or a draw. Okay, that makes sense. Card is selected. Spade, club. Yep, we did that. A, B, C, D, we did that. Oh, good. Red, green, yellow. Good. Oh, from the letters of the word alphabet. Silly me. Okay, I thought it meant the whole alphabet. Okay, and she hasn't written A twice because there's 2 A's in the word alphabet, isn't there? Alphabet. Right, so I apologise. Alright, now task 3 wanted you to open the Google Slides and have a look at this one. So let's have a look at the answers and I'll explain them to you. And list the sample space for each of the events. So you have to do the same thing. So go and open the Google Slides when you get a chance. You can have this ready as you're going. So the first one says tossing an octahedral 8-sided die. So you don't have a 6-sided die this time, you have an 8-sided die. So that means you're going to have numbers 1, 2, that's already there, 3, 4, 5, 6, 7's already there, and you're going to also have an 8. So there are all the possible answers you could get. Here, selecting a marble from a bag with red, blue, black and white marbles. Pardon me. So your answer is going to be red, blue's already there, black and white. Pardon me. Selecting a season of the year. So hopefully you all know there's a summer, there's an autumn, there's a winter and a spring. And noting the colour on a traffic light. So hopefully you know there's 3 colours on a traffic light. There's red, there's green and there's orange or yellow, whichever you prefer is fine. And noting the number on a spinner with the sectors numbered from 1 to 6. So all the possible answers are 1, 2, 3, 4, 5 and 6. Okay, simple probability. So now we're going to write our answers, pardon me, in fraction form. Let's have a go. When determining simple probability from single-step experiments, it's important to understand the following terms. Now, if you've watched the video, this is what the man on the video was talking about. An outcome is a particular result of an experiment. All right, so if we're going to toss a coin and we want to get a head, the outcome we want is the head. A favourable outcome is an outcome that we want or that we're looking for. So sorry, in that case, a head is the favourable outcome. And the theoretical probability of an event can be calculated using the number of favourable outcomes over the total number of outcomes. So you'll get a fraction, just like you did before. The top is the number of how many times we got what we wanted, and the number down the bottom is the total possible number of answers you can have. Now, as I said before, probabilities can be expressed as fractions, decimals, or percentages. Now, not very many people did this one, so I'd like you to do this one with me now on the video if you haven't done it yet. A 6-sided die is rolled. You'll have to go back to Friday's lesson. Write a fraction which describes the chance of rolling a 3, but first determine the following. Number of favourable outcomes. So it said write a fraction which describes the chance of rolling a 3. So what do we want to get? We want to get a 3. So there's only one 3 on a dice, isn't there? So the number of favourable outcomes is only 1. State the number of all possible outcomes. Okay, well, think about a die. There are 6 numbers, aren't there? 1, 2, 3, 4, 5 and 6. So there's therefore 6 possible answers, aren't there? Okay, and the next one, consider the rule. So we put our first number 1 on the top, we put our second number 6 on the bottom, and that is our answer. Okay, example number 2, a 6-sided die is rolled. Write a fraction which describes the chance of rolling an odd number. Alright, so here are all the odd numbers that are on a die. 1, 3 and 5. 2, 4, 6, the ones that are missing, they're even numbers, aren't they? So there's 3 numbers, so that's why our number of favourable outcomes is 3. State the number of all possible outcomes. Well, how many numbers are there on a die? Hopefully you said there are 6, miss. So that's why that one's 6. So you notice down here, we put a 3 on the top, we put a 6 on the bottom, and then we attempt to reduce that fraction. Hopefully you notice 3 goes in as 6, okay, twice. So the number on the 2 becomes a 2. And 3 goes into 3 once, so the number on the top becomes a 1. So 3 over 6, 3 is half of 6, so our fraction is a half. Alright, so then it said open Google Slides, simple probability, and do all of that pretty much again. Okay, so I'm going to go back and I'm going to see if I can find that one for you. That's not the way to do that. That one, isn't it? Alright, let's have a quick go at this one, because this one had quite a few in it. Alright, we're just doing all of that. So, for a 6-sided die, write a fraction describes the chance of rolling a 1. That's done for us. Oops, sorry about that. I've just spat all over that. My apologies. There are 13. Let's try number 2. There are 13 white marbles in a bag of 20. So, how many white marbles are there? Not sure if this is going to let me write on it. Do I have to go like this? Come on, you can do it. Okay, let's see if it's going to let me write on it. Will it let me write on it? Maybe. Let's see. Alright, so 13. The number of favourable outcomes. Edit slide. Right. Let's see. Will it let me write? Sorry, don't know how to use this very much. Let's try. Oh, no, I don't want that. I just want to write, goobers. That one? Nope. How do I write, kids? Oh, well. Okay, doesn't matter. Alright, so the number of favourable outcomes, that's 13. It's not going to let me write. Okay. I want a colour. Can I have a colour? 13? No. Alright, doesn't matter. No. Alright. Number of possible outcomes is 20, so your answer should have been 13 over 20 for that one there. Let's try the next one. For a spinner with 8 sectors, numbered 1 to 8, write a fraction that describes the chance of rolling a number greater than 5. So a number greater than 5 does not include 5. Okay? Greater than 5 is 6, 7, and 8. So the number of favourable outcomes would be 3. Number of possible outcomes would be 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. So number of possible outcomes would be 8. And the number greater than 5, would be the first number 3 over the second number 8. So 3 over 8. Question number 4. Write a fraction that describes the chance of a public holiday falling on a weekend. Okay, how many days are weekend days? So the number of favourable outcomes is 2. Number of possible outcomes, how many days of the week are there? There are 7 in total. So public holiday falling on a weekend would be 2 over 7. Next one, write a fraction that describes the chance of a randomly selected letter being a consonant. Well, A, E, I, O, U are vowels, so everything else are consonants. Okay, you've got 5 vowels out of 26, so 26 minus 5 is 21. So there are 21 consonants. So number of favourable outcomes is 21. Number of possible outcomes is 26. So your probability would be 21 over 26. If a red card is randomly selected from a standard deck of playing cards, write a fraction that describes the chance of selecting a diamond. Okay, so if you had a look at that other sheet where the cards were, you'll know that every suit, that is all of the clubs, there are 13. All of the spades, there are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. That's how you get 13. All of the diamonds, there are 13, and all of the hearts, there are 13. So altogether, there are 52 cards, because 13 times 4 is 52. So number of favourable outcomes. So how many did I say were diamonds again? 13, alright? Every suit has 13 cards, so there are 13 diamonds. So number of favourable outcomes is 13. Number of possible outcomes, so altogether in a standard deck of playing cards, there's 52. So your probability of a diamond is 13 over 52, which if you use your calculator, you'll know equals a quarter, or 1 over 4. Last but not least, a child is selecting one shape from a square, a rectangle, a circle, a triangle, and a rhombus. Write a fraction that describes the chance of a child selecting a quadrilateral, which is a 4-sided shape. Now a square, has that got 4 sides? Yes, it does. A rectangle, does that have 4 sides? Yes, it does. A circle, does that have 4 sides? No, it doesn't. A triangle, does it have 4 sides? No, it doesn't. And a rhombus, which is a squashed or a pushed over square, it's also got 4 sides. So out of all of those, there are 3 that have 4 sides. So number of favourable outcomes is 3. How many possible shapes do we have there? 1, 2, 3, 4, 5 altogether. So your answer would be 3 over 5. A multiple choice question, question number 8, has the following answer options: A, B, C, D, or E. If a student is guessing, write a fraction that describes his chance of getting a correct answer. So the number of favourable outcomes, write a fraction. Okay, so you can only get one of those, can't you, in a test? You can't get all 5. You can only get one of them. So number of favourable outcomes is 1, because you can only get 1 grade, either hopefully an A. Number of possible grades you can get, well, there's 5. So your correct answer would be 1 out of 5. Okay, so only one of those answers in a multiple choice test would actually be correct. Okay, right, let's move on. All right, where are we? Let's see if I've still got it open. Okay, so we've done all of that. All right, let's go back to this one. So we've done all of this. Let's see if it'll open up in that other one for me again. Alright, have we already done some of this? Yes, good. It's the one I've already done. Excellent. Okay, so let's go to these, because lots of people hadn't had these done just yet. Right, here's my pen. Groovy. That's better. Alright, so here, task 5. Read through the questions below and write your answers on the worksheet. Leo has been given a bag of marbles to play with. Inside the bag there are 3 blue, 6 green, 6 red, 4 green and 7 black. How many marbles are in the bag? There are 3, 10, 11, 12, 13, 20 altogether. So that one should be a 20, shouldn't it? If Leo takes 1 marble from the bag, calculate a probability of getting a red marble. So how many red marbles are there? 6. So your probability would be 6 out of 20. Reduce that. What's half of 6? Half of 6 is 3. And half of 20? Half of 20 is 10. So there you go. Either use your calculator or use your head. What's the probability of getting a green marble? How many greens are there? There are 4 greens. 4 out of 20. Can you reduce that for me? Half of 4 is 2. Half of 20 is 10. Now can we halve those numbers again? I think we can. What's half of 2? It's 1. And half of 10 is 5. So your final answer could be 1/5. Next one, getting a black marble. Alright, how many blacks are there? 7 out of 20. Can we reduce that fraction? No, I don't think we can. Getting a blue marble. There are 3 blue marbles. So 3 out of 20. Can we reduce that fraction? No, I don't think so. Okay, next one, C. How many marbles in the bag are either blue or black? There are 3 blue and 7 black. So there are 10 that are blue or black. Probability of getting a blue or a black marble. So we put that combined answer of 10 over our total answer of 20. Now, can I reduce 10 over 20? Is 10 half of 20? Hopefully you said yes, so I can reduce that down to a half. Find the probability of getting a green or a red. So let's go. Let's add green and red together. So green is 4, red is 6. So what's 4 plus 6? Hopefully you got 10 again. 10 out of 20, and the same as before. Does 10 fit into 20? Twice? Yes, it does. So my answer is a half. Right. What about getting a green, a blue, or a red marble? So let's count all those together. Green, blue, and red. 3 blue, 6 red, and 4 green makes 13. 13 out of a possible 20. Can I reduce that fraction? No, I can't. All right, next one. Getting a red, green, blue, or black. Well, that's all of them, isn't it? So that's 20 out of 20. And 20 out of 20 is the same as? Hopefully you said 1 whole. Explain your answer to part G. Okay, well 20 out of 20 is the same as 1 whole. Now I have to go to a meeting now. I apologise, Year 7. I will try and do a video later on that goes through these answers with you. Okay, see you soon. Bye.